Hello, I'm Raphael Pereira and I'm here to present my EMath 1 assignment. So, for question 1 here, we just have to sub in the values of B and C, 3 and 5. For our first column, we have the first curve, which is y equals to x squared, represented by the blue line over here. And for the orange line is our quadratic curve. So, we have to sub in the values of B and C, as I said before, and in addition to that of x. So, using the formula over here, B12, which is 25, plus relative position F4, which is 3, times A12, which is x negative 5, plus relative position H4, which is 5. And that will get us 15. And basically using this formula to get the rest of the values in the column. This is our graph over here for the two curves. On to question 3. Numerical discriminant will be negative 11. And this reflects on the curve, our quadratic curve over here, because it does not intersect the x-axis whatsoever. And the formula I use to attain the discriminant is right here. So B, which is over here, F4, relative position F4 square, minus 4 times A, which is 1, times C, which is 5, in relative position H4. So therefore, we'll get these two solutions here. And since square root of a negative number, you get a complex number. I've expressed it in this form. And formula is b square, sorry, not b square, negative b plus square root of the discriminant divided by 2 times a. And since it is a square root, obviously you have positive square root over here for the first value and negative square root for the second value. For question 4, this has to do with the input and output shift. So to obtain the completed square form, first it's x plus b squared, but you need to divide b by 2. So 3 divided by 2 will give us 1.5 over here. And then we add c, which is 5, minus b divided by 2 square. And that should get us, from this formula here, 2.75. So our completed square form should be x plus 1.5, squaring the whole thing, plus 2.75. So converting our equation, our quadratic equation over here to complete the square form, we can see that it should shift up by 2.75 and shift left by 1.5. And lastly, with regard to the discriminant, as I've mentioned in question 3, since the discriminant is less than 0, it should not intersect the x-axis, and therefore no real roots should be, we should not have any real roots. However, if the discriminant were to be equivalent to 0, as you can see over here, it should only intersect the x-axis once, as you can see here. It's quite hard to see. And finally, if it were more than 0, it should intersect the x-axis twice. And with that, we've come to the end of my presentation, and I'd like to thank you for your attention.